So this is going to be my answers to the 2019 AP Calculus AB FRQ response, question number 2. And the question says, the velocity of a particle p moving along the x-axis given by the differentiable function v sub p, where v sub p is measured in meters per hour and t is measured in hours. Selected values of v sub p are shown in the table above. Particle p is at the origin at time equals 0. Part A says justify whether there must be at least one time t for that interval at which v prime of t, the acceleration of the particle p, equals 0 meters per hour per hour. And the answer to that is the average rate of change over that interval is 0, and because the function is differentiable, it's therefore continuous. Therefore, according to Rolle's theorem, v prime of t must equal 0 at some point in that interval. That should make intuitive sense, but it's important to explicitly state that it's differentiable, therefore it's continuous, and to explicitly state the name of the theorem, which is Rolle's theorem. You can say intermediate value theorem too. They're really the same thing, just Rolle's theorem is where it's 0. And part B says use a trapezoidal sum of the 3 subintervals to approximate the value of that interval. And the first step is to calculate each area of each individual trapezoid, and that is going to be the area of a trapezoid, you should remember, is base 1 plus base 2 over 2 times the height. So for here, the first area is going to be equal to, the bases are the respective velocities and the height is the time interval. So 55 plus 0 over 2 times the height of that interval, which is 0.3, which is equal to, where's my calculator? There it is. 55 divided by 2 times 3, which is 8.25. The second area is 55 minus 29 over 2 times time interval, which is 1.4. This is 55 minus 29, 1.4 divided by 2, which is 18.2. And then the third area is equal to, again, 55 minus 29 over 2 times the time interval, which is 1.1, which equals 55 minus 29, 0.1 divided by 2, which is 14.3. And the integral from 0 to 2.8 of Vp dt is approximately equal to the sum of these values. I'm just going to use shorthand notation. The graders will understand it. The sum of a sub n, which is 8.25 plus 18.2 plus 14.3, which is 40.750, and it is a position. It's the integral velocity, which is position, so that is in meters. So that's the answer for part B. Part C says the second particle Q also moves along the x-axis. That velocity for that interval is given by a separate function. I'm going to go ahead and divide down the calculator just to be quick. Vq of t is equal to 45 square root of t times the cosine of 0.063 t squared. Find the time interval during which the velocity of particle Q is at least 60 meters per hour. Find the distance traveled by particle Q during the interval when the velocity of particle Q is at least 60 meters per hour. So first you need to find the interval, right? And the easiest way to do it is by graphing. So this is, it says Vq of t is at least, which is less than or equal to 60. So that means Vq of t is minus 60 is greater than or equal to 0. So we can go ahead and graph that function on our calculator, because we already defined it. Vq of x minus 60, and it's from time t to time equals 4, so it's this interval right here. Get the zeros right here. The 0, 1.87, and 3.52. So that's for 1.87, is less than or equal to t, which is also less than or equal to 3.52. And it says, find the distance traveled by particle q during the time interval. The velocity of particle q is at least 60 meters per hour. So it says distance traveled, and the distance traveled here is the same as displacement because it's never changing direction, because q of t is always positive on this interval, right? So simply integrate vq of t over this interval. So 1.87 to 3.52 vq of t dt, which is equal to, our calculator, integral from 1.87 to 3.52 vq of t dt. This is 105.929. And don't forget units, which are meters. Quick note here. Ideally, your time should have 3 decimal places, but mine don't, just because the graph didn't work out that way. My calculator doesn't work that way. If yours also didn't work out that way, I'm sure it wouldn't matter as long as your final answer is anywhere close to it. So part D says at time equals 0, particle q is at position x equals -90. Use the result from part B and the function vq from part C. Approximate the distance between particles p and q at time equals 2.8. So at time equals 2.8, we need to first solve for the x-coordinate of particle p at time equals 2.8. And this is simply, we're going to say xp at 2.8. It's going to be equal to xp at time equals 0 plus the integral from 0 to 2.8 of x prime with respect to time. We already found this result from before, which was 40.75. This integral is 40.75, and this is also 0 because it explicitly states that particle p is at the origin, time equals 0. So this is equal to 40.750, and x q at 2.8 is equal to x q at 0 plus the integral from 0 to 2.8 of vq, or we'll say x prime of q of t dt. Sadly, you can't just integrate that and get your answer, because it explicitly says use your answer from part C, which I hate, but you have to do that. So we're going to work this integral out using our answer from part C. So the integral from 0 to 2.8 of x, or we'll start calling it vq dt, is equal to the integral from 0 to 1.87 vq dt plus the integral from 1.87 to 3.52 vq dt plus the integral from 3.52 to 2.8 vq dt. And that's simply just the property of integrals. You can integrate over these bounds this way if they add. So from 0 to 1.87, 0 to 1.87 vq of t dt, this is 76.209, which equals $76.209 plus the answer we had from previously, which was 105.929, plus the other integral here, which is 3.52 to 2.8 vq t dt, which is negative 46.201. So we'll make that a negative 46.201, which which is equal to 76 plus 2.09 plus 105.929 plus 46.201, or minus 46.201, which is 135.937. And that means, well, it gives you that x at time equals 0 is negative 90 plus this value of the integral, which we calculated to be 135.937, and this is 45.937. And the distance between particles Q and particles P and Q is just the difference of those. So we're going to denote that distance is equal to 45.937 minus 40.750, which is equal to 45.937 minus 40.750, which is 5.187 meters. And that is my solution to number 2.